Okay, good morning, and thank you for joining the second day at OCP. Today we're going to talk about bringing open networking to the campus networks, creating a solution that we call the OpenLAN Cloud Managed Switches. So we heard in the previous OCPs about solutions based on vendor-owned versions of SONiC, but this time we're showing that this can be done also with open source SONiC. This solution was created by the OpenLAN Switching project under the Telecom Infrastructure Project, or TIP, and it brought both open source to the campus network, but also a notion called Cloud Managed Enterprises, or CME, which is a new trend that campus networks want to operate at. We know the success of open networking in data centers, in the hyperscalers, but this one, and this brought the freedom from the lockdown of the big system vendors. And this time we want to bring similar benefits also to campus networks. And this is what we're going to talk today. My name is Gidi Navon. I'm from the Switch CTO team at Marvell Semiconductor. And here with me is Chornyi, who is the director of open networking at PLVision. PLVision is a software company specializing in SONiC and in open software solutions. So first thing to recognize that this work was a teamwork of multiple companies. So on the foundation, you have companies like ourselves, like Marvell, that bring the switch silicon. You may know that we have the Teralynx family, which is aimed for the hyperscalers. We recently announced the Teralynx 10 that brings 51 tera of switching in a single device. But we also have the Prestera family, which is optimized for the campus networks. And then we have a variety of hardware platforms, and it's the first time we see so many hardware partners that are committed to run open source on their platforms. The network operating system, what a better choice than to select SONiC as a network operating that brings all the benefits of routing and overlay and its containerized architecture. But this didn't come without challenges. So we have companies like PLVision that are working on optimizing and trimming down SONiC so it can fit to the cost-optimized silicon. Now, the new thing that we're bringing is what we call the cloud management. So we created an interface to companies that are specializing in cloud management. Instead of placing network management systems on-prem, here you have the management is done from the cloud. And companies like Shasta Cloud, which is also the driving force of the OpenLAN switching activity, is the one that is providing this as a service. A few words about this OpenLAN switching activity under the Telecom Infrastructure Project. So it was built under the foundation of the Open Wi-Fi, which created open Wi-Fi access points. But what became clear is that you need to aggregate those access points using a switch, 8-port to 48-port switches, depending on the network size. And you need to connect to those access points not only using 1 gigabit port, but also using 2.5 and even 10 gigabit to connect to the strong Wi-Fi 7 access points. And you need to power them with PoE and PoE++. Now, utilizing SONiC was great because it brought all its benefits, but even basic things we found are missing. I'll just we'll talk about it later, but an appetizer, the PoE management was missing. So last month, Marvell contributed to the SAI, to the OCP SAI management for the PoE, and it's now part of SAI 1.14. So apart from open software, we are also embracing open interfaces. And this is why we created this open interface to the cloud management that can pass through the public internet and includes also zero trust provisioning. And again, we'll talk about it later. But apart from that, we also wanted to create a validated and hardened solution. So unlike when you talk with hyperscalers that they can test and validate their solution, when you go to campus networks, they want an out-of-the-box, ready-to-be-used solution. And this is where the TIP came into place to validate the solution. Now, when we looked about the special aspects of campus versus cloud, so we saw in the cloud, everything is well organized. The topology is repetitive. You have really trained personnel. that can even build their own orchestration software. But in the campus, it can be an unattended, automated warehouse that have no personnel. It can be a variety of topologies, endless topologies. It can be a retail with surveillance cameras and sensors. It can be a small office with just some access points and some printers. And in addition, the new thing of cloud management is instead of placing a management system on-prem, you want to manage everything from the cloud. Also, the installation and the provision, you want to stand the box using a courier, open the box, and plug it in, and it just works. And from the technical aspect, you cannot rely on very strong multi-core Intel CPUs. You need to cope with moderate, maybe a dual-core ARM with limited amount of RAM and flash. But on the other hand, also the capabilities or the needs are not as high. I mean, the scale is limited, the functionality is limited. So this allows us to trim down SONiC and create what we call the OLO SONiC, which is still open source, but optimized for the campus use cases. A few words about the stack, about the layering. So here you see in the center, the switch, a 24, 48-port switch, aggregating Wi-Fi access points and IoT devices, all centered around the Marvell Prestera switch that comes with a full SI SDK. The switch also includes PoE components that also needs to be managed. And then, as I said, PoE management is now part of SI 1.14 that we contributed. The network operating system is SONiC, and companies like PLVision, which are continuously trimming and optimizing the solution to run here. And the main new thing that we created was this uCentral client, which runs as an agent inside a SONiC container, connects to the SONiC northbound interfaces, and create a secure connection to the cloud. In the cloud, we have a cloud SDK, which is also an open source package, which is the infrastructure for all the cloud management, the GUI, the management, etc. And you have companies like Shasta Cloud that are developing this GUI and working with system integrators to provide the full solution. Another additional key aspect is the zero trust provisioning. So the device is authenticated using a TIP certificate authority and receives back indication to which cloud provider I need to connect and to be managed by. And after this secure connection is established, you run all your regular management, you push the configuration down, you receive telemetry, you receive events, doing software upgrades, etc. Basically, we are creating like a self-driving network. So we mentioned that there was a variety of hardware platforms ranging from 1 gig to 2.5 with 10 and 25 gigabit uplinks. We have also solutions with not only most of the solutions are with internal CPU, but we have also solutions with external CPU if you need to run a very strong applications on top of SONiC. And all those solutions are centered around the Prestera switch. So we have switches optimized for 1 gig and 2.5 gigabit uplinks, but we have other switches which are more for 5 gig and 10 gigabit copper interfaces, which are needed when you connect to Wi-Fi 7 access points. I will not go over all the features of the switch. I want to mention the inline MACsec. And when I say inline, it means that you don't degrade the performance when you enable MACsec. And we see more and more interest in MACsec, especially for out-of-building installations like a surveillance camera that you want to protect the connection to the building. We mentioned the dual-core ARM CPU that can hold the SONiC image, and we'll talk about it later. And the CPU is coming with a secure boot and secure environment. And we also have aggregation switches that we are planning to add to the solution. And those switches are not entry-level switches. So while not all features are already part of SONiC, we're capable of adding more advanced tunneling, microsegmentation. We have programmable engines there. So it's a safe vehicle to build on and add more and more features as you go. So I'll now hand it over to Taras, who will spend more about the technical aspects, about the optimization we have done, and the roadmap.
Yeah, thanks, Gidi. Hopefully you have your morning coffee today and ready to listen about what we did. And as Gidi was saying, the main concern about putting the SONiC on the campus level on the cost-optimized switches is resource utilization. SONiC was designed and built and is heavily successful in data center where you control everything and the price of the extra CPU core is almost negligible. Within the campus network, it's a bit different story. You want to squeeze as much as possible from your software, from your hardware, to lower the BOM cost of the overall solution because the numbers are just order of magnitude bigger of the number of platforms you deploy rather than the data center. So what we did, we started with the simple thing, which is quite obvious. We've disabled the features that are DC-oriented and not needed in the campus, which allowed us to lower the RAM consumption of the SONiC as well as the storage consumption. As well, we've moved the all baseline Dockers to the slim images of Debian, and these simple things allowed us on the T0 config for SONiC to hit the sweet spot of under 4 gig of RAM for running the OLS NOS image and under 8 gig of storage needed to have the dual partitioning on the device itself. So how we plugged the uCentral client to the SONiC. As Gidi was saying, uCentral client is the Docker image running within the SONiC container, and you can see it on the right top corner. Basically, in SONiC, there is an app extension mechanism, which allowed us to introduce new functionality to SONiC natively. So what we did, we've implemented that container with that client configuration that is responsible for working with the SONiC NOS-bound interfaces like GNMI, GNOI, REST, and it's also managed the partition with the certificate to authenticate the cloud. And the most important part of it, what it does, is it takes over the SONiC local ZTP because ZTP in SONiC is available, but it's mainly for the DC use cases, so with DHCP related or any other things you can do. Here, we took over this functionality and implemented the support for over the public internet global ZTP. I will explain how it works later on. It also implements the secure connection to the cloud based on the TLS and WebSockets. The protocol itself is JSON-based schema available in open source. The best thing about this is we not limited the adopters and vendors to use only SONiC. The client itself is also platform agnostic, and there are support already in place in the community domain for other. There is a proprietary SONiC flavors and even non-SONiC Realtek-based solutions. So, and here I would like to point you how the global ZTP over the public internet works. So at the first step, when a box is being produced by the vendor, the certificate is being installed on the box. The certificate identifies the box in the global domain. When hardware is shipped by the vendor or by the distributor, the information about that specific box is being sent to the cloud provider that this box was sold or has to be managed by. Once device is received by the end customer or by the location, all you need to do is to connect that device to the internet. Any port will work. Once the internet is detected, the first thing the device does is connects to the global redirector, where the information about which cloud is supposed to manage this device is stored. This information is pulled back, and device connects securely to the cloud and gets its updates, current configuration, and being managed from the cloud from now on. And this is a sneak peek of the overview of the cloud management software, and thanks for our friends in Shasta Cloud to providing this facility to play with it. It's production-ready system, starting from SONiC devices and the cloud management. As you can see, nothing new here. You can control your switch in any case in the way you've used to. You have your ports configuration, your network configuration. You can see your events, alarms. You can add extra information. How did you deploy it? There is another. You can see your standard telemetry, amount of traffic. Again, alarms, how many devices connected, how many disconnected. And everything is ready, but there is much more things to be done in future. So the SONiC itself, as I was saying, and as Gidi was saying, was designed and quite successfully running currently in data center. Campus has a bit different architecture, a bit different requirements for the NOS to fulfill. The most important one is the security requirement. So usually, like 99.99% of the campus deployments, you do have the .1x deployment. You need the power over Ethernet and power over Ethernet++, the latest 90 watt standard, because the Wi-Fi 7 needs it, and you need to support it. You do run your XSTP set of protocols to prevent the loops. You might need to have the VLAN transition. You might want to have the MAC-based or policy-based VLAN assignment, and some extra features like telemetry, etc. As of today, we did add, as Gidi was saying, Marvell contributed to the SAI implementation for the PoE. PLVision been working with Marvell quite closely here, and we are currently in the process of contributing the PoE functionality to the mainline SONiC. We are using this in the OLS image as well. The spanning tree, there is a whole group in SONiC that is aimed to identify and help to close the gaps from the functionality-wise to cover the campus use cases. Just to reiterate what we've listened today and what we heard today. So from the top down, there are a set of companies like Shasta, Intelio, NetExperience that provide network as a service solution, and they do run it in the, as their main product, and based on the SONiC optimized open source OLS image that runs on the hardware platforms from different hardware vendors, Celestica, Vistrom, EdgeCore, which is all run on the cloud optimized silicon, which is most importantly, I believe, future proof. As Gidi was saying and I was mentioning, there are still more things to come, but platform wise, it's available, it's in silicon already, and we will catch up with software, and we're doing it right now. So what is my call to action for today? The main thing, we need to work together with all community, and thanks for all of our friends in Marvell, but it's not just Marvell, with all switching silicon community to extend the SAI to cover what's needed by the campus networks. It's more or less covered now still. Some things may be added, and the special work group is already working on that. Additionally, while we are working with SONiC, we need to understand that it's not DC anymore. There are other use cases we want a SONiC to be, so we need to design the functionality, we need to implement the functionality in an optimized manner, when we do need to realize that there is another use cases where it's quite tight. We also need to extend and standardize overall northbound interface of the SONiC. It's a bit painful now how disorganized and fragmented it is, and we are working with SONiC community to make sure it's harmonized and available through all flavors of the SONiC. I would ask you to join the OLS Wi-Fi, OpenLAN Switching, Open Wi-Fi work groups to contribute to your use cases, your questions, or start using this. As I said, the solution is production ready, it's deployable, and additional information can be found under the OpenLAN Switching work group or under the OLS schema, where you can see what's available and what's not. And thank you for your attention, and if you have any questions, please feel free to ask. There are systems in production right now, and if you are talking from the Wi-Fi perspective, there are hundreds of thousands of Wi-Fis already in productions. From the switching perspective, there are thousands of switches already in productions. There are several cloud companies that do provide this on the commercial basis. Shasta Cloud is one of them. There is like Aurelio, NetExperience, and other companies that do deploy it in production from the switching perspective.
Fact that
supports remote upgrades from the cloud. I was mentioning this maybe not clearly during this slide. So once the device connects, once device is connected to the cloud here on the step 5, the cloud identifies who this device is, what the version of it, and if needed, pushes the remote upgrade to the device itself over the same central client. So it can do new software, it can do configuration, it also supports monitoring, remote TTY if needed. So you do have the flexibility provided by the cloud SDK here. You do have the flexibility to control device if you, as you wish, basically as almost your local controller. But because it's the cloud SDK, you define the logic, what your operators can do. So for example, you want to disable the RTTY, you want to disable the events collection. It's you to decide what's supported, what's not.
So in terms of upgrade, is this solution supporting full image upgrade?
Full image upgrade as of today. Partial image updates is planned, and currently the plan is to support per container because SONiC is containerized based. The patches itself, it's a bit tricky one because there is no like simple patch system in SONiC available as of today. So we do recommend to have the full upgrade. If you want to have the security one, you can run your partial upgrade either through the SONiC, through the up extension mechanism, or through the Debian upgrades mechanism. It's all available.
And how you are managing the upgrade failures? Do you have a mechanism to roll back
It's dual image support. So, and the way how do you upgrade and roll back is controlled by you. You have the possibility to initiate it, get the status of it, and then you decide what to do next. If something failed, you can roll back